welcome to my lesson. Everything working? Question mark? Yes, everything's working. Everything is in working order. Now, I structured this whole thing, especially also with in mind. Hold up a second. I have to check something. Okay, I'm looking straight when I'm looking like that. Yes, okay. Just was weird for a second. So first a little bit to me. I'm Didi. I have been a tutor for 5 years for the Schule Institute Düsseldorf, which was formerly Schule Becker. We have the main subjects being mathematics, English, and economics, secondary chemistry, biology, and physics. So if you have any questions about these subjects, you can ask me. Currently, all of my willing students have improved their grades. Then again, those were always programs specifically tailored to those students. A little more, I finished the A level with focus on economics and English, and have a bachelor's degree in economics, mainly on HR management, leadership, company management, and work psychology. I think that's the most important part. Now, starting with the whole thing, basic algebra. I also have to take down the music for me a little bit. I'm hoping it's not too loud. Give me a second. Okay, that's a level that works for me. If at any point it's too loud BGM for you, then please don't hesitate to tell me. I'll turn it down a bit. Yep. Now, the theme of the first lesson is the first lessons. There will be more than one because there is way too much to cover here, and I'm gonna cover it all based upon each other. So the first one would be basic algebra. So that's the first theme, and within this we are starting with equations. The plan currently is cover what is an equation. Nope. What is an equation? That looks silly. Yeah, what is an equation? Then covering linear equations, quadratic equations, and those would be it for today. Next would be equations with powers, including cubic and every other kind. Solving systems of equations. Partially I will cover that in the linear equations, but we'll see what the time allows. And afterwards, in the end of all the lessons, we will have examples in real life and little Q&A if you have any questions regarding the topic. So first, let us define what an equation is. And I have two definitions. Number one that I thought of myself, and number two that I just copied that a lot of people want to hear. My personal opinion doesn't say anything. The second one, represented by a series of characters, an equation of two mathematical quantities. Basically means there are two, which I'm gonna name terms, meaning you have two descriptions of a mathematical problem that are connected by an equal sign. And look at that, that's my definition. An equation describes two or more terms connected via an equal sign. which is the basic grassroots, what it basically means. Now, for an equation, we usually have to define the numbers that are in there. For those, we are taking three different definitions of numbers. Since those are the most used ones, there are others, but those are either too advanced for this class or do not really get used at all. Like, for example, there's also the n, which is kind of full numbers above 0, which is kinda, yeah, nice it exists, but we don't really need it. At least not for our purposes. What we have here are the full numbers, rational numbers, and real numbers. The full numbers also including the negative ones. So going from -1 to 0 to 1, 2, 3, and so on. Now, rational numbers are numbers that you can work a lot with, like the... Hold up, give me a second. I have to double check. Yes, any number that can be written as a fraction, where the numerator, like the top number and the bottom number, are not the same as 0, but the integers of one other number, meaning like 1/2, 1/3, 34/5, and so on. Real numbers are pretty much every number that exists. Like every number that we can't just make up BS of. Like the root of 2. Or I think the square root of 17, for example. I know it's hard to see. It's smarter if you put me on, full screen. But you do you. Also represented here, you have the different circles. One of them, the full numbers, is one of the smaller circles. Inside this circle would be n, or all the full positive numbers. They're part of that, expanded by the real numbers, and including those and the the not real numbers are not the rational numbers, and the non-rational numbers together with the rational numbers make together the real numbers. That's the basic definition, and usually most people don't have a problem with it. Now, going to the equations, the way that they are separated usually. I'm gonna say usually because, sometimes people say all of these are exponential equations, because technically, yes, they are. They all are an unknown to the power of something. But for convenience sake and for understanding sake, we will first take care of the linear, or we will differentiate into linear. Hi Jay, yes, actual. actual maths because hi, I'm doing great. It's actual maths because I'm actually a math teacher. I know, who would have figured. So yeah, separating into linear, then quadratic, and the exponential. Linear being everything that is x to the power of 1. Give me nightmares from differential equations in uni. I have to be honest with you, differential equations for me was actually a school subject. I did not have that. I think they were repeated in uni as well, but I mainly had those in school. Then the quadratic equations, x to the power of 2, and the others x to the power of 3 to n with the according coefficients. But yeah, it's I mean, I get that those were a nightmare at some point, but like once you understand them, it's really easy. And I can tell you, I had trouble with those in school as well. Like a real lot until like 11th grade, where I just tried to relearn all that stuff, and then it clicked, and then it was smooth sailing from there. Like from 11th grade on till my 13th grade, I never learned for a mathematics exam again, because it was necessary. Because if you get the basics, everything else builds on those basics. So yeah, let's define linear. A linear equation is a mathematical conditional equation in which only linear combinations of the unknowns occur. A linear combination of an unknown is x to the power of 1. Meaning we can just write it as x. That's the linear part, because the graph in and of itself, because there's usually to every equation you can almost every equation you can make a graph. In this case, it's linear because the graph is a line. The graph is linear. Next one, the quadratic equation is an equation for the univariate case in the form of y or f of x equals variable x to the power of 2 plus b times x to the power of 1 and c. With a, this is important, the first one cannot be equal to 0, because 0 times anything is 0, and then we'd have a linear equation. Yeah, a, b and c being the coefficients, and x is the unknown that we're trying to solve towards, or y in several functions. If nice color again, if b equals 0, meaning if b is out of the whole thing, you have a purely quadratic equations, just the quadratic equation, no modifier to it, and the movement on the y-axis. Oh god, this is gonna look like a nightmare, because I have to draw with my mouse. The function itself looks about like this, also being called a hyperbole, I think. Hyperbole should be the right term in English. And the last part being the exponential ones, where you have several different variants that we will be talking about. Exponential equations include linear and quadratic equations. However, the term exponential is usually used to describe the unknown x to the power of 3 or higher, usually cast as y equals a times by x to the power of 3 plus b times x to the power of 2 plus c times x to the power of 1 and adding d and adding coefficients and powers as needed. So if you have the power of 4, you would have ax to the power of 4 plus bx to the power of 3 and so on. Their graphs are different. Yeah, x to the power of 3, if I remember correctly, should look about like this. And x to the power of 4 should be just a different kind of hyperbole. But like, look something like that, because I'm drawing freehand, and freehand is I should really get myself a drawing pad just for this. So yeah. Also, the same applies here. The variable a is never equal to 0, because then we will have a different kind of equation. Going on to linear equations, because this one's already gotten a bit of a cluster. The basic formula. There are two ways. I learned it with y equals mx plus n. There's also the 0 equals ax plus b. I personally like to work with this one because that's how I learned it, and how I learned to do a lot of ways to solve them. And yeah, those go from me from my mind. What is important for all equations? That looks bad. You can only have, or what is right with the linear equations, but not all equations, is that you can only have one defined solution. But all equations need to be, or all solutions for an equation need to be defined. Meaning you have to make a definition for them, which being x is the element of the real numbers, whole numbers, or rational numbers. Looking at this, you only have one x to the power of 1, or you only have x to the power of 1, so you can only have one solution. Otherwise you don't have a linear equation. The basic formula as described. Here m, or a, this modifier, this coefficient, can be 0. If it is 0, then y equals b or n. Hold up, I'm gonna mark that in a different number. Different color. Y equals 0, y equals n. That is an actually acceptable one, and if you have y equals n, then you get a straighter line than I just drew. A perfectly straight line in that height. For example, the x-axis in the coordinate system can be defined as y equals 0. Another important part, it shows a linear graph when you put it into a coordinate system. It is linear. The way it rises does not deviate. This little thingy. You can put the perfect triangle here with a 90 degree and it always stays the same. uh, the these angles of the triangle are always the same, no matter where you put the triangle. We could put the triangle. Give me another color that we can see. This one. You can put the triangle here. We can't see that color. That's too bad. Let's try it in gray. We can see these are always the same as these. A usually defines the angle of the graph, being here. I'm not gonna show that today because that's way more advanced. B usually defines the height, like the y position where the graph starts, which is why when y equals b or n, you get a straight line. And B always defines the origin of the graph, being the same as the position, the origin on the y-axis. With x being 0, meaning the graph's origin, from where the graph goes on into the world. So yeah, that's the absolute basics about that. Now, linear equation. How do we treat linear equations? They can only be solved one way, which is reforming and then calculating. For an example, we have 16 equals 4x plus 8. We subtract the 8 from the one side and this side, getting 16 minus 8 equals 4x, resulting in 8 equals 4x. Divide that by 4 to take away the 4 from the right side to get it over here, and then we will have 2 equals x. This would look about like this in the coordinate system. This is it's a rough sketch of it. One should note that I just have to check that the 1, 2, 3. Note that the value of n often defines the intersection with the y-axis. At this point, 0 and 0 on the x-axis and 0 on the x-axis and 8 on the y-axis, meaning the graph has to go through here, which is also a useful tool when you have to draw those. Also, the intersection with the x-axis is where y equals 0. So in this case, 0 equals 4x plus 8 minus 8 is, if we subtract 8, means minus 8 equals 4x, meaning divided by 4 is x equals minus 2, meaning the coordinate here, it's hard to see, this coordinate is minus 2 and 0. Yes, pretty easy so far. Let's try with some... Oh god, now I'm making it harder for myself. No, I don't know Twitch. How do I do this? Can I? No, I can't. Let me figure this out. like this. And left side is OBS. Thank you. Now this works as I would like it to, so I can still see my chat. You go somewhere down here. Yeah, sure, go there. Yep. Yep. Give me a second to drink. Tasty water. I'm gonna just pour myself some more. Since we have linear equations now, we can test what I have just gone through in less than 20 minutes. Not hard to tell what these are about. It's harder to actually use them. Let's use a text and type in 3x equals 21. I'll make it bigger next time. I'm gonna do a subheading. So first operation we're doing, 4x equals 21 divided by 3 makes x equals 21 divided by 3 means x equals 7. Yes, 7. I didn't just make a mistake. Perfect. Now for something more complex. Since this is very, very basic. Something a lot of people also have had, at least have had issues with, is if we do 13 equals x minus 3. Let's take 2x minus 3, minus 2x. Now, the first thing we'll do is add plus 3 on either side. Coming to 13 plus 3 equals minus 2x. Being 16 equals minus 2x. Then what a lot of people have problems with is the minus in front of the 2. So here we divide by minus 2, not just 2, because I'm gonna go through this for now. If we divide by 2, we get 8 equals minus x. And then we are left with a question, what do we do now? If we are smart, we divide by minus 1, because you have to imagine there is a 1 in front of this x, because 2 divided by 2 equals 1. Otherwise the x would be gone. So we divide by minus 1, meaning minus 8 equals x, which is a step more, and mathematicians don't like doing many steps, so yeah, mathematicians don't like doing more steps than is absolutely necessary. They're very lazy writers. They're very, 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 very lazy in writing. So we just combine that into 16 equals minus 2x and divide that by minus 2, meaning minus 8 equals x. And there it is. That's the next solution. I want to and then do Oh, bright blue. This turns to this. That way I can differentiate them later on as well. Or anyone joining in between. Next example. 21 minus 2x equals 6x plus 5. Let's solve this one for fun. I mean, for our purposes here. The first thing we're gonna do is we want to have x on one side and make it as simple as possible. We don't want any of that minus stuff on any side of the equation if we can help it. So we are going to add 2x. That way we have 21 minus 2x plus 2x equals 6x plus 2x plus 5, which would result in 21 minus 0 equals 8x plus 5. Yes. Or 21 equals 8x plus 5. I should really use my numpad more. Next step we are going to do. Now, we have a 5 on the right side and a 21 on the left side. We have x all on one side. Let's get rid of the 5, shall we? And minus 5. Meaning we are at, give me a second, 16 equals 8x. All we now have left to do is divide by 8, and we have 2 equals x. Perfectly easy, reasonable, I hope. I hope this can be recognized somewhere. To mark it as 1. Hold up. Yeah. Let's mark it as one of them. And let's do another one. Just for training purposes. I'm going to put in here something. 15 minus 5x equals 2x minus 20. If you're thinking this is too much of exercise or examples, this really is not. In German we have a figure of speech saying Übung macht den Meister, meaning training makes perfect. Like with everything, sometimes with these you have to really do it a lot of times so that, you know, it just goes into your body, your soul becomes part of you, and you don't have to think about doing it. You just do it. Like me, I just stop and start thinking because I'm doing it in English, and English is not my first language. And because I'm trying to explain it as well. So, I technically have given you enough seconds time to do this. So I'm going to show the way to solve it now. First thing we're gonna do is add 5x because we want to get rid of this one. Going into 15 equals 2x minus 20. Next step, getting rid of the 20. This is weird. Okay. Getting rid of the 20 on the right side, putting it on the left side. Meaning 35 equals 2x. What do we do now? Divide by 2. Meaning... yeah, that's not beautiful, but 22.5 equals x in this case. Have I done it right? Yeah, I should. Let me double check. Yes, I done it wrong. Because I added 5x, but I didn't add 5x. Because that's supposed to be a 7. I was confused because in these examples it should be all full numbers. So 35 divided by 7 is 5. Divided by 7 is 5 equals x. And as you see, even a teacher can make mistakes. So what color are we gonna give you? Let's give it pink. Yes, thank you. This one and there. Nope. I didn't want to. Okay, I'm learning new things about Canva. Good to know. Those are now entities that I can move. I did not know that. I thought they were connected with this. Just gonna move it to the side here. Nope. Not what I wanted. Can I? Thank you. Now, for the next example, let's make it a little bit more complicated. Complicated example. Minus 44 minus 12x equals minus equals minus 15x plus 12. I wanted to have an x here as well. Important. Let's go zooming in again. Nice. Now, what do we do first? We add 12x. Meaning we have minus 44 equals minus 3x plus 12. Now, what do we do next? Huh? Yeah. I'm not singing, so that goes into the wrong throat. So. Holy hell. Already 40 minutes. 40 minutes just talking about linear functions. That's crazy. Where was I? Where was I mentally? Give me a second. Yeah, I have to check. Yeah, 40 minutes. 42. Oh boy. That's a lot. I can't mute it up. Okay. I want to know how my big BGM is. If that's too much or if it still is okay. Well, we'll see later. Now, next thing we'll do is subtract 12. So we get to minus 56 equals minus 3x. I actually wanted to make this. Well, I wanted to make it a stumblestone. Now, what do we divide it by? What are we going to divide this whole thing by? Just by 3? By 3x? Or by -3? Well, no chat doesn't say anything, so I'm gonna tell that now. We divide it by -3, and we don't use the enter key between those. So, first things first, both numbers become positive. So the right side becomes x. Now, 56 divided by 3 is annoying. No! Equals x. I wanted to... 56 divided by 3. 3 times 10, 3 times 20 is 60, minus 3 is 57. 3 times 18 is 30, 3 times 8... 3 times 10 is 30, 3 times 8 is... memory don't fail me. 24. So 24 plus 30 is 54. Means there's 2 left. No. 54. 2 left. Equals 18 point. I'm saying it, but I'm not doing it. Nope, wrong key. 2 is left. We can't divide 3 by 2, but we can. Can't divide 2 by 3, but we can divide 20 by 3. 20 by 3. No, we can't. 21 can be divided by 3. That's 7. Means we're doing 0.6. Which means it's 18 below there. Meaning we get again. One thing I hate about this. Meaning we get 2 again. Meaning it's 18.6. 1667. Let's round it up. Yep, let's round it. Yep. That's better than nothing, I suppose. It works for what I'm trying to show. Magenta. And yes, I really wanted some numbers that are where I could get into the negative pitfall. So I modified something that I prepared in advance. Because when I looked in advance, I did not realize that. Let's make an easy one to conclude. And... nope, don't draw it. An easy one to conclude. 3x plus 7 equals 11 plus 19x. First we're gonna do is subtract 3x. Get it from one side to the other. Always keeping it positive. Meaning 7 equals 11 plus 16x. Now we subtract 11 again, meaning we get oh god, all the brain. 7 minus 11 is minus 4 equals 16x divided by 16. Minus 0.2 equals x if I'm correct. No. Minus 0.25 equals x. Nice. Nice and easy one for the conclusion. And that one's gonna get some... What do we wanna mark it with? Let's put it orange. Nice. Nice. I want to see if I can... I solved all of these, but I didn't make a graph. So we're gonna make one that I'm gonna put an approximate graph for. So we have the function of x equals... What could be fun? What could be interesting? What could be annoying for students? Minus 3x plus 2. That sounds like it's annoying. Nope. Nope. That's not what I wanted. And we have to find... Looking for... What are we looking for? Intersection with y-axis and x-axis. Now, intersection with y-axis. Easy and straightforward. 0 equals minus 3x plus 2. Plus 2. Oops. Plus 2. 2 equals minus 3x. Divide by minus 3. Yeah. Nice. That looks better. And then we have 2 minus bracket 2 divided by 3 equals x. Intersection x-axis. Condition for an intersection with the x-axis is... Oh, damn it. Got the wrong way around. With the y-axis is x equals 0. Meaning y equals minus 3 times 0 plus 2. Congratulations. if we see here, the intersection with the y-axis, gonna make this in red, is always this. Because you can only intersect the y-axis when x equals 0. Y-axis can only be intersected when x equals 0. And that is important for every single equations. Every single equation. Yes, going back to linear, or going back to our beautiful thing here. No, wrong one. Going back to here. The coefficient without an unknown is always the intersection with the y-axis. Now where do I put that? Would be beautiful down here. Hold up a second. Nope. Now take this one away. This one away. No, I would just want this gone. Don't want my design to go. Let's make it a bit smaller. Yes. That looks good. Now, going to the next point in all of this, being quadratic equations. Quadratic equations almost always have two defined solutions, or any given quadratic equation. Hold up, let me write this down as a sentence to remember. Any given quadratic equation has at least one solution. Solution, but no more than two. If you have more than two solutions to this, then you're doing something wrong. Because in the end it's supposed like this. Like the graph is supposed to look like, you know, this hyperbole. Wouldn't make sense if it had, you know, more than two solutions, because that would mean you have more than 2 points intersecting with the x-axis, which doesn't work at all. Now this is not beautiful anymore. This is annoying. A, or the basic formula to this, is y equals ax to the power of 2 plus bx plus c. A cannot be 0. Absolutely not. Like from now on, every equation that is higher than a quadratic equation needs this first one. Because without the a, it's not a quadratic equation anymore. If a equals 0, then we have a linear equation. I hope that makes sense. That's it may sound dumb, but that's a really important point that many students overlook. Like, way too many students overlook this. Now, the graph it shows a quadratic graph. When put into a coordinate system, which is also called a hyperbolic function or a hyperbole. Important to know. I don't know why, but usually teachers or tests want to know those words. C usually defines the y position, or where the graph intersects with the y-axis. In this case, it's C. In the end, it's the C. In this case, the no. We'll keep that. We already wrote it down here. The coefficient without an unknown is always the intersection with the y-axis, with very little exception. So yeah, we have this one. And in our example, the basic function intersects the y-axis at 0, 0, like at the origin of the whole system. Leading to the next step, the very exhausting one, which a lot of people have problems with, because a lot of people have issue memorizing this important formula. No, wait a second. Let's make it. Okay. This important formula by heart. If you know this formula by heart, you will never have issues with any quadratic function. I can guarantee it. If you know this by heart, whenever you get a quadratic function and you're asked where a certain point on a graph is, you will always find those points. Always. Absolutely zero exceptions. Again, only within quadratic equations and quadratic functions. Doesn't work for cubic functions, does not work for cubic functions, does not work for linear functions, works for quadratic functions. So, how do we get to there? First, we will look good to color. I like yellow. Let's take yellow. First, we look at the basic function. The basic function is y equals ax to the power of 2 plus bx to the power of 1 plus c. Now, the first thing we're gonna do is put y on this side, so we end up with 0 here. This formula only works if we have 0 equals ax squared and so on. The c minus the y part, which is where the p and q come in, is always up. Let's mark it down. No, I don't want to do it in red. I'm gonna do it in green. The c minus y part and q is the same. Not me having a hard time showing all of this. So yeah, c minus y equals q. It's important. That way, with that in mind, you can find any point on the graph, which looks very very troubled in my example. Let's try this again. Yes. So like, if we are going for, let's say, what colors do we have? Let's take pink. If we want to know the x values for this point, for y equals, let's say this is y plus 4. We can either read it off the graph, or we can find out with this. And then in the end, the P and Q function, or the PQ formula. I don't quite know how it is taught in English, but where I come from, it was taught as the PQ formula, or is taught as the PQ formula. Very, very important. I cannot stress enough how important it is to learn this formula by heart. I'm now gonna take this away as well, because it's for the example. Now, let's do it with an example. How to solve at the point of 16. 2x squared plus 2x plus 2 equals 16. First thing we're gonna do is take the 16 over here. Following along so far? We calculate minus 16, and I've seen I made a mistake down here. Meaning that's not the square root of 17. That's the square root of 15. Meaning we will calculate that later on, but with a calculator, because I don't know many people who can do that in their minds. So we have 0, important part, equals 2x squared plus 2x plus 2 minus 16, meaning 0 equals 2x squared plus 2x minus 14. Now, the formula, the PQ formula, and we put in this case, P is the 2, and Q is our minus 14. When we put it into the formula, minus 14 times minus 1, because you have to remember this minus Q is minus 1 times Q. Nope, I'm gonna put it as a small text below it. Minus 1 times Q. A bit smaller, so it's about the size of this equation. I'm gonna put it below it so you can see it, I hope. Yep. The important part is, no matter if the Q here, if the Q here is a positive number, doesn't matter. These two lines indicate that we only work with the value of it. So if in the end we get something like square root of the value of minus 15, it becomes the square root of 15. Now, going on. Now we put all this into the formula. Minus p divided by 2 plus and minus p divided by 2 squared minus 14 turns into minus 2 divided by 2 is minus 1 plus and minus 2 divided by 2 is 1. 1 squared is still 1 because 1 times 1 is 1, meaning 1. Then minus 13, minus 1 times minus 1 is positive, or I say plus, so this becomes plus 14. So 1 plus 14, meaning it's the square root of 15. That is technically where you can end it. Like writing it out like this: minus 1 plus square root of 15, minus 1 minus square root of 15. Because the square root of 15 is a real number, but it's an irrational number. Meaning it's not as easy to... Hold up a second. Before I'm talking nonsense, yes. Okay. It is an irrational number. I wasn't wrong. I was right. An irrational number is a number that you that you can't technically write down with numbers behind the point. Yeah, I mean you can round it, but it's like it's not periodical, like 18.6666666 or something like that. Like 1/3, for example. That's still a rational number because it's a periodical number. But irrational numbers, like pi, for example, are indefinite, but they don't follow a period. They aren't periodical, meaning instead of 0.666 you have like 0.153028142 or something like that. So yeah, that makes it an irrational number. Yes, I actually had to check for a second so that I don't tell you some kind of bull, you know, that I tell it to you right. And because it's an irrational number, all we can do in our decimal system is put something there that's like close to it. We can only round it up, put something about equal. So we have -1 plus the square root of 15, which is about 2.873, or you can put 2.87. That's up to you. Now let's okay, -1 minus the square root of 15 equals about -4.7. 0.873. Yeah. Irrational numbers can happen. They can happen quite a lot in these systems. We can't do anything about it. It's just the way roots work. Yep. But you know, there's worse things in life. But yeah, it's technically... technically, this is a solution. You have two solutions, meaning you have 2 points where you about can find that. By the way, 2x squared plus 2x plus 2 should look about like this. Think of it as smoother, not as janky as I'm doing, right? Yeah, about this. Yep, about this. Maybe a little bit too high, like this. What we can see from the graph and what we can see from here, all these numbers are positive. Meaning this graph will not intersect the x-axis. You can often predict where the intersection with the x-axis is. By these following criteria. C is bigger than 0 is the first part of the first criterion. A and B are both positive, meaning you have a hyperbole going like this, and it's above, like it's above the x-axis. It doesn't touch the x-axis. Absolutely not. No touchy. Like with your favorite VTubers, no touchy. What? There are there is one case. It is, let's say, it's unlikely that it intersects the x-axis because we never deal in absolutes. There could be some kind of irrational number that you could replace A for that could make this, I don't know, just barely touch the x-axis, that could modify it to, let's take pink for that, to kind of look like this. Not smooth on one side, but like, hold up. Let's over exaggerate. Yeah, I don't want it to snap into shape, my friend. Like this. There may or may not be irrational numbers that can do that. In those cases, you know, yeah, it's BS, but what you gonna do? Same case, if all are bigger than 0, if all are also smaller than 0, if all are negative numbers, if A and B both are negative, and C is negative, there's most likely no x-axis intersection. Same case as here, because those would look like this. How's that gonna touch the x-axis? It won't. It absolutely won't, because it's not circular or anything. It doesn't spin back around like this. That would be a sinus function. It stays there the way it is. And yeah, that's basically the important part. You can also kind of, usually you can see it if you say, no, I don't want white. What color haven't I used? I'm gonna use red for this. To find out where it intersects with the x-axis, all we need to do is replace y with 0 here. And sometimes you can already see, like if you only have this part. Hold up. Let me put a shape here. I don't want, what the hell? No. You're gonna be black. And I want you to be in the front. You're gonna like it. I'm just gonna put it here because I need to see what I'm doing here, because I'm taking this base formula. We put the text here. Then we'll make the text white. Become white, my text. Yes. And now 0 equals 2x squared. Did I press the wrong button? I pressed the wrong button. Plus 2x plus 2. You see the problem? It's always positive. We can say minus 2. Minus 2 equals 2x squared plus 2x. Good luck finding a way. Because no matter what you do, white is probably a bad color. Yellow. This one is always going to be smaller than this one, meaning the number cannot be negative. Like, this is not solvable. Just to show it as an example. So yeah, as you see down here, 0 equals 2x squared plus 2x plus 2 doesn't have a solution, meaning it does not touch the x-axis, because where y equals 0 is exactly the point. It's like where y equals 0 is exactly here, where both the x and the y axis intersect. So now that we've talked about this, let's go to our examples, shall we? Gonna move this one out of the way. Go a bit over here. Erase you. Oh, free sheet! And do some examples. Give me a second. Now, this VOD is going to be available on YouTube, because you know, I want to branch out into my educational stuff, and this is my educational stuff. So, yeah. Mm. So, next part is yeah. Now, I've been talking a lot about examples and not doing anything. X square x car x squared equals 9. I'm too far. I'm zoomed too far out, aren't I? Nice. Put it up here. So what we are now gonna do is annoying because Canva doesn't show me that option. We're gonna pull the square root. The square root is the most basic root. Yes, root. R-U-U-T. Yes. Square root. Root and route. Difference. Yes, I also struggle with the English language sometimes. So we take the square root, which leads us to x equals square root of 9, which is 3. Yeah, it's like, it's best if you memorize this, if your memorization tables like 1 times 1, 2 times 2, 3 times 3, that up to 21, and you're golden. If you learn that to 21, up to 21, that's, you're golden. Because a lot of these things you can just do in your head just by remembering. In fact, let's do that right now. Let's make a table, a memorization table. 1 to the power of 2 equals 1 times 1 equals 1. 2 to the power of 2 equals 2 times 2 equals 4. 3 to the power of 2 equals 3 times 3 equals 9. 4 to the power of 2 equals 16. 5 to the power of 2 equals 25. 6 to the power of 2 equals... Anybody? Nope. Too bad. 6 to the power of 2 is 36. 7 to the power of 2 is 49. 8 to the power of 2 equals 54. Yes, 54 is nuts, I know. 9 to the power of 2 equals 81. 10 to the power of 2 equals 100. 11 to the power of 2 equals 121. 12 to the power of 2 equals 144. 13, 14, 15, 16, 17. Can we make 20? Let's see. 18, 19, 20. Yes, we can. To the power of 2, 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 to the power of 2. Now, I think that was 156, but let me check for a second. That's the easy part of calculating written down. 13 times 13 equals 1 times 10 times 13 is 130. 3 times 13 is 30, 36, 166. No. 169. Because 3 times 3 is 9. Haha! So it's 169. That means you are 190. I'm getting in trouble here. I'm the math teacher. I'm supposed to know. 40 plus 4 is 40. 4 times 4 is 16. 56, 196. Okay, I was right. This equals 225 if I'm thinking correctly. Let's prove it. 15 is 150. 5 times 15 is 55. It's 225. It's not 55. 15 times 5 is 50. 75. It's still it's 225. I was right. I'm gonna just put the equal signs all here before I'm gonna say it. 21 to the power of 2. What I remember already is 400. Meaning 21 times 21 is 421. No, 431. Because 21 times 21, 20 times 21 is 210. 1 times 21 is 21, so 431. Yep. Luckily, those are in between. Next one, because we're on a roll. 16 times 16. 160. 6 times 6 is 36. Now 6 times 16 is 96. Meaning we are at 256. If I'm thinking correctly. 256. No. 256. 56. Dang it. Language. Huh? Next one. 17 times 17. One thing I can tell you. There is a 9 at the end. Because 70. 7 times 7 is 49. 7 times 7 is 70, so 70 plus 39 is 119. So 289. Yes. You see, I struggle because I don't have haven't memorized them correctly. 180 plus 8 times 8 is 54 plus 8 times 10 is 80, making the sum 160 260, 314. 314 is here. And 19 times 19. 81. 190. And 90. Because 9 times 9 is... yeah, okay, you can see it. So that's 280, 371. If you want to make your life easier, you're going to memorize the whole table up to 21. Because you see, I lost valuable time with that. Usually if you're in a test, you don't have that time. Not like me right now. I had the time, technically, because I planned on making x squared the last part of this lesson. Because I'm now at 1.5 hours, and 1.5 hours is a lot of time for a lesson. I'm gonna make it maximum 2 hours, because concentration for everyone paying attention will be gone by then. So yeah, I recommend to you memorize this table from 1 times squared to 21 times squared, which was also an advice from my math teacher, from my last math teacher, where I always earned good grades. So in theory, there was a point in my life where I had those in my head, where I had those memorized by my brain. But you know, the older you get, the harder it is to remember something. Old man syndrome. I mean, what? So, next exercise. Talking almost non-stop for 1.5 hours is exhausting. But you know, I'm used to it. Let's put this here. Put this away. So, next one. 2x squared plus 2 equals 100. That's a little too many pluses. So, first step we're gonna do minus 2. Minus 2, not minus 25. 25 is a bit too much. We will ruin our fun. Now, 2, not 2 squared, I don't want 2 squared, I want 2x squared is equal to 98. Then we will divide by 2. After dividing by 2, what do we do next? That's the right person that didn't say anything. Why do I know you're right? Because I can read your mind. That's a joke. X squared equals 98 divided by 2 is 4. No, is 9 is 49. Next is the square root of 49. I have to make this one a bit smaller. Question mark. Yeah, that's gonna work. Square root of 49. What's the square root of 49? Let's look at our table. It's 7. x equals 7. Usually we have to look at the table in our head though. Yeah. And that's it. Next exercise done. Now, what else can we do? Something harder. Harder. 4 minus 5x squared. A little bit of body. So 4 minus 5x squared equals minus 16. Well, it's gonna be a doozy, isn't it? First thing, minus 4. 5. No! What are you doing? Didi, what are you doing? Minus 5x squared equals minus 20. And now it's fun. Divided by minus 5. Now minus 5. What is minus 20 divided by minus 5, everyone? What is it? Come on. Yes. Oh, I'm sorry. Sometimes I like to write it right to my own chat for bullshit. Yeah, it's 4. Meaning x squared equals 4. Then of course we take the square root because we have nothing better to do. Meaning x equals 2. Because 2 times 2 is 4. Yay! We are learning basic mathematics. Are you having fun yet? I don't believe you if you say you do. Because a lot of people think this is tedious and not fun at all. I can't really fault them. Because yeah, it is tedious. But like, it can be fun if you let it be fun. You know? Like, if you really force yourself to enjoy it, then it can be fun. Yeah, I'm not making this sound any more appealing, right? I'm not making it sound any more appealing. But no matter. No matter. It can get worse from here. Believe me. It can get worse from here. So let's put this up here. X equals 2. And erase this one. No. Ooh. One with a variable on both sides. 5x squared plus 12 equals x squared plus 3. Now how is gonna go and solve that one? How is gonna go and solve that one? Any suggestions? I am open to suggestions. No suggestions. Too bad. Then we have to make the following. First step we do. Minus x squared. Why? Because we want x squared only on one side of the formula. Meaning 4x squared plus 12 equals 3. Hold up a second. Hold up a second. Now minus 12. This is gonna be disgusting, isn't it? 4x squared equals minus 9. 5x squared plus 12 equals x squared plus 3. The solution is gonna hurt. Divided by 4. X squared. Hold up a second. I gotta look at this. No. It's supposed to be. Okay. Divided by 4. X squared equals minus 9 divided by 4. The astute among you? The astute people among you know that a square cannot be negative. We cannot have a negative square. Now we're standing here. Now we've been made a fool. Can we find another way to solve it? 5x squared plus 12 equals x squared plus 3. Let's do it. Maybe I just made a mistake. Minus 5. X means 12 equals minus 4x squared plus 3. Minus 3 is still 9 equals minus 4x squared. And that divided by minus 4 is still minus 9 divided by 4 equals x squared. So you see, there's no solution. Those happen as well, unless I made a mistake. But I can't seem to find it. Let me take a closer look. 5x plus 12 is 9. That's 9. No, because I can tell you now, because technically this always has to be bigger. Like, hold up. Let me draw on it. This one always has to be bigger than this one. So yeah, no solution. Come on. No solution because because x squared can never be negative. Importante. A square can never be negative. If you do minus 2 times minus 2, it's still plus 4. You know what I mean? So it can't work. Let's be honest, the textbook I stole that from does not have a lot of these. So I did not think that would be the one. But hey, we found one without a solution. Pachi pachi. 1 hour 45. Holy hell. Let's go for x squared plus 4 equals 0. X squared plus 4x equals 0. Now we know something. There's a good old friend we can use here. A good old friend we can use here. This good old friend will help. But you ask me, why would it help? Because technically we can also write it like I just gotta check if it's just x squared plus 4. Yeah, we can also write it x squared plus 4x plus 0 equals 0. So x1 2 equals yes, I'm pulling out all the stops. Equals, give me a second. Minus 4 divided by 2 plus minus square root of open bracket 4 divided by 2 squared minus 0. Which comes to a lot of trouble, a lot of work. x1 2 equals minus 2 plus minus 4 divided by 2 is 2. 2 squared is 4, and the square root of 4 is 2. Meaning x1 equals minus 2 plus 2 equals 0. x2 equals minus 2 minus 2 equals minus 4. And there you have it. Now, the proper solution for this. The proper solution is x is the give me a second. I have to check the amount of solution. Okay. The amount of solution for x is x where do I have my definitions? Where do I have my there? X element of real numbers and and x one, no, not xy, x1 is equal to 0 and x2 is equal semicolon x2 equal to -4. Definition: x the element of the real numbers, and x and 0 is bigger or equal to x being bigger or equal to -4. Yes, that's the solution. Technically, x is either -4 or 0, but for mathematics purposes, because we don't want to deal in absolutes completely, x is in between those. It's BS, but like this one should be sufficient. This one is if you want to be a nerd about it, which technically mathematicians are, so let's be nerds about it. Yeah, that's the solution with the answer sentence. We'll do a few more exercises. How many did we do here? 2, 4, 6. We have so far done 3, 4, 5. Okay. Gonna be one last training version, and then yeah, after one last training version we have been at this for 2 hours. And then I'm gonna switch over to Stardew. Give brain some rest or something else. Something I don't need a brain for. What games do I not need a brain for? Oh god. I have to think in Stardew. That's the problem. You know, we get to it when we get to it. Right? We'll get to it when we'll get to it. So. Ooh, I found a complicated one that can be fun. Oh yeah, by the way, this here, you can technically find out by guessing as well, but I don't like guesswork. Unless it's specifically asked of the students, but like, why would you if you can prove it? If you have a formula and you know that formula by heart, I mean, use the formula. Now, actually I have 2 that are gonna be very unfun because they are complicated. X squared. I can't copy it like that. I will have to screenshot it and put it in here. Can I just copy this one? Can I copy it? No, I can't. Let's make do. Fuck it. X squared. Put this in brackets. X squared thirds minus 5 divided by 3 equals 0. Now, this looks a bit complicated, but we can still put it in here. No, we can't. Dang it. Okay, we'll find another way. Let's, I'm gonna call it simplify slash switch some stuff, because 1 divided by 3 times x squared minus 5 times 1 divided by 3 equals 0. If we get those 1 divided by 3 out, then we would be golden. Problem being, we can't. Because the other side is 0 and you can't divide 0. So no solution, because division by 0. Now why do I say that? If we were to say 1 divided by 3 times x squared, which is just another way to write this one, 5 times 1 divided by 3 equals 0, and we divide it by 1 divided by 3. Now we get x squared minus 5 equals 0 times 3 divided by 1. Because 3 divided by 1 divided by 3, the 3 carries up to the 0, that means 3 times 0 divided by 1. And 3 times 0 is still 0. So we would get 0 divided by 1. And you can't divide 0. 0 is still 0. Oh, hold up. Sorry. You can. Because you can't divide by 0, but you can divide 0. Sorry. Correction. X squared minus 5 equals 0. Now we either have our beautiful thing here, or we just add plus 5 and say x squared equals 5. Haha, I almost made a mistake by... Almost made a mistake. Means x equals... We have to do the square root of 5, meaning x is the square root of 5, which is not a rational number. Yay. No fun at all. I see one more that I want to do. That's x divided by 2, open bracket, 3x plus 1, close bracket, equals x squared minus 2x. Now, how do we get rid of this one? That's a 2, not a 1. First thing we're going to do, because I want to get this divided by 2 out. we're gonna do times 2x, or like we're gonna times 2 the whole thing. That way we get x, open bracket, 6x plus 1, wrong bracket, equals 2x squared minus 4x. Then we solve the brackets. 6x squared plus x, oops, that's a 2, plus 2x equals 2x squared minus 4x plus 4x. 6x squared plus 6x equals 2x squared. Now that's interesting. There is a solution to this. I can also tell you the solution right now. Because we don't have anything else that adds in. There's only one solution. Can you guess the solution? What times 6 plus what times 6 equals 2 times itself, 2 times that? Well, the solution is pretty easy. Why don't we put 0 in for x? That means 6 times 0 squared plus 6 times 0 equals 2 times 0 squared. In the end, 0 equals 0. That means x equals 0. Pretty easy if you see it, right? Kinda dumb, not gonna lie. Feels like a bit of a cop-out. But you know, luckily I'm not the one who wrote the textbook. So yeah. We have also gotten somewhere where we get the solution of 0, which is nice. Hey, page A, partial differentiation. Give me a second. I'm gonna look it up. Partial differentiation. Give me a second. Partial differentiation. Give me a second. If you don't mind, I will take a second. I'm sorry, what grade are you in? Because most that I teach is just homogeneous, non-homogeneous. Oh. Okay, that explains. I'm used to doing the school stuff. If you give me a few minutes to read into it, then I can probably get it done. Engineering in college, partial differentiation. Oh my. Oh my, oh my, oh my. Okay, if I'm on the spot like that, I can't help you. Okay, no, that would take me a few hours to read into. I'm sorry. I'm very sorry about that. Jesus, that's a lot of things. I'm sorry. I'm one of the dumb people who studied economics. Sorry. I wish I knew what that was. Diffusion. Okay, no, sorry. That's for now beyond me, not in a short amount of time. But I'm gonna, you know what? I'm gonna write it down for myself. Partial differentiation. It may be then too late for you, but you know, I can read up on that and make something. So yeah, if you have another theme next time, you can just DM me on Twitter if you have Twitter, or come on Discord and write that. I think I have a channel there somewhere about these things. I'll read up on that and make an explanation video or an explanation stream. Define calculus. There's quite a lot to calculus. Yeah, it's gonna be hard to do, but I can do it. Yes, I know about calculus. It's a secondary education in my country. Oh, but I had it. I haven't done that in ages. That's gonna be a challenge, but it's gonna be interesting. If I'm thinking correctly, that's like, if you have like Euler's function and try to take a tangent at a certain point, for example, in differential calculus. I usually teach grades 5 to 13. So like technically like 5 to 10 in the primary education, and secondary education in Germany is like A-level stuff, which is 12th and 11th and 12th grade, technically also 13th, depending on what school it is. Yeah, that's what I have been doing so far, at least. But differential calculus is not done that often and that deeply. I checked the differential calculus. Hold up. I checked calculus on Wikipedia, what all goes in there. I have never heard of the Leibniz notation. Gonna check that. The one thing that I can do is integrals from my first overview. The fundamental theorem of calculus states that different Integration or the inverse operations. More precisely, it relates the value of antiderivatives. Give me a second. I'm gonna. I'm sorry. I have to read that in German to easier understand. Now, tell me what differential calculus. English not being my first language is now becoming the problem. Hold up a second. Even if I can't explain it, I think I know someone who can, if you wanna go quickly. Come on, please. Please tell me these guys have it in English as well. Studyfix.com. Mother trucker. Okay, I'm sorry, I can't even recommend these guys because there are some guys called Studyfix in Germany. Or Studyflix, and they are very good. Problem being, they're not offering their stuff in English. I'm gonna ask them to do that. Calculus. Tangent lines, functions, independent variables, dependent. Okay. I'm sorry. In the future you could learn it from my YouTube, but that's gonna be a problem now. But I wish you the most success in your exam tomorrow. You know, after you watch that YouTube video, take some time to relax and, you know, you'll do it, I think. I'm a teacher, not a professor. There's a minor difference. I'm technically a school teacher, and professor is a bit above what I am. I have not written a doctor thesis or do not have a commission as professor anywhere. Just basic math teacher at school, which is my basic stuff. But next thing I'm gonna do probably then is also make my script available once I'm done. I work a lot with things that I was taught in, or I copy a lot of ways my professors taught me in university. Like, for example, scripts where I upload somewhere so someone can easily either follow the whole thing or, you know, have something as a reminder. But if... Thank you. My personal goal is bringing education as far as possible, because in my personal mind, education is the one thing that can curb most of the world's problems, or like a lot of the world's problems, like you know, crime and terrorism. Because how do you fight it if you don't give people... No, my students don't know. And currently I'm quite happy about that because my students don't need tutoring sessions. Luckily, they all do very well, which I'm very happy about because that tells me I am not a failure as a teacher. I also don't make a lot of I also don't make money tutoring people because usually it takes 2 or 3 lessons with me and then they're done and don't need a tutor anymore. Yeah. The usual problem with students is they miss 1 or 2 of the basics somewhere. And once they have those, everything else just comes in without any problems. Which is the the fun part about it, I think. That's I think like when the students are happy that they're doing good and that you're preparing them well for the future. That's all I can ask for. But yeah, differential calculus, it's hard. I'm currently still working on my equations with powers, my cubic equations, which I didn't want to cover right here because I'm already 2 hours in, 2 hours 15, 16, and nobody could concentrate that long for a lesson. So you would need a big break. So yeah. My next target is exponential functions. Machine learning. Oh my. I know a few VTubers who have studied programming, but I don't think that's the same. I'm quite... Honestly, that's that's going quite a bit out of my element. Machine learning is a bit much for me. I can write simple bots, but that's all. Yeah, those are next level lesson. I'm like all of them are technically exponential, like square and linear and so on, or quadratic and linear. But like the ones I want to focus on are like cubic functions because their graph is different as well. Because you for those functions you have you have a graph that usually looks like this. And then x4 is usually just a hyperbole like x squared, so I'm gonna put those under modifications like x by the power of n. I also wanna cover one special thing, which is Euler, which is e hoch x, e to the power of x, which is something important that students should have or should know, like stuff by the power of x. But yeah, that is all the stuff that I want to cover in my equations. That is what my plan is currently. And I think after that I'm gonna go for statistics for now. Oh, I will do. I will crop and edit these streams and put them on YouTube. First I'm gonna put in the VOD. Because sometimes in the VOD you get like questions that are frequently asked or asked by students, and that could help another student out. And I want to have those available. For the themes I do, I want to crop them and make like the explanation videos for linear functions, quadratic equations, and so on. And then put like an FAQ to those videos as well. I think that would be, you know, spreading education all over the world. My golden aim. Because if you know stuff, you're less likely to do dumb stuff. Less likely. I mean, I'm a VTuber, so I'm still doing dumb stuff. But yeah, I will also go into stuff like that. Once I'm done with all the school subjects, I will cover some more university grade stuff, especially stuff that's called in engineering, machine engineering, and so on. Yeah, being a VTuber is great. I mean, when it's hot outside, you can sit there with your t-shirt off and don't have to worry about anything. Which is, I think, one of the benefits. I don't want people lusting over my body. Yeah, I thought so too. I have not seen... I mean, personally, I have not seen any VTubers teaching stuff like mathematics or economics, which is what I'm going to do. I'm still trying to figure out on what time frame. Yeah. I'm most relaxed when I do, like, when I wrote my bachelor's thesis and so on. I felt most relaxed when I was sitting in as few clothes as possible. Then again, it was in summer, so 30 degrees in your home is a problem, is a real problem. But yeah, studying, I mean, everyone has their style of studying, right? Yeah. To be quite honest, for mathematics, I did not study a lot, neither in school nor in university, because everything kind of builds up on each other. The only thing I memorized by heart were my square tables, like from 1 to 21 squared, and certain formulas. Those were the ones I had to memorize. Well, I trained them by writing them down 1,000 times, doing a lot of exercises with them, and once I had them in, they were in, and they are currently in for the rest of my life. Yeah, it's true. Germans don't really use AC. The only places you get an AC in Germany is either in a hotel or at your workplace. At home, we don't really have ACs because we open our windows during the night often. Like a lot of Germans that I know, and myself included, open their windows during the night, and during the day we have the blinds down, and our blinds are really good, so if the blinds are down, pretty much no heat gets in from the outside. Like, I can go to my workplace for 8, 9, 10 hours and come back to a room with about 20 degrees Celsius. If I... give me a second. In Fahrenheit... which is like... oh, sorry. Wrong conversion. Which is like 68 degrees Fahrenheit. So yeah. Like, we don't... the reason we don't use AC usually is because we don't need AC. Oh, okay. I don't need to... yeah, right. You're machine engineering, right? You're one of the few people that... oh, you only know Celsius. Okay. Just for fun, what country are you from? because I don't know many countries where you would go to school on a Saturday. Or to university at a Saturday. India makes sense. Makes sense. Now the third Indian person I know who was at least was in the mint, one of the mint subjects, because all the Indian people I know have studied mint subjects in university or at an academy. Like in Germany we have something called dual system or dual studies, which is like half the time you're part of a company and working there, and the other half of the time you're studying at the academy or slash university. They're the same things. And you work full time, like a real employee. So you get the work experience at the same time as you get all the theoretical stuff pumped into you. Which I think is a great system, because you not only learn the theory behind it, but you can actually use it, like practically. And since mine, it's hard. Like the bachelor's is condensed into 3 years, and it's like very, very hard. Like in Germany we have 2 systems for work education. There's one that's called Ausbildung, which is kind of like job training in a sense, which goes 3 years. And then you study a bachelor's for 3 years. Then again, the state where I live in is very special about that, because Saxony and Germany, that's hardcore. We have the hardest A-level in the whole country. We have the hardest requirements for university and so on. It's quite annoying. Like when you go through with like a grade of like 80% in Saxony, in the rest of Germany you would be at either 90 or 100%. Which not many companies appreciate, sadly. But you know, I don't have to worry about that because I'm paid by the state. Plus, the harder it is, the easier it gets in the real world, because in the real world, it's usually easier. Then again, in economics we learned stuff that was quite interesting, that is taught nowhere else. We had like matrix, like when we learned how to calculate with a matrix, we also learned certain out-of-date models that are technically out of date, but you can actually use in modern times with companies that buy from each other, like there's like Tetra. You know, that huge Indian company that has a huge steel mining business, car business, and I think tool production as well. And with the Leontief model, you look at how those are interdependent and how you can, how the influx of production in one has to, or demands the influx of production in the other ones. Which is quite interesting, because it's from a former communist country and a communist theory. You know, some principles are always the same, no matter what system you're in. Yep. It's really nice. Yeah. Now I'm done with teaching my current lesson. I'm sorry I can't do much in the way of engineering. it's honestly, by the rate I'm going, it would be next year that I would be touching upon that subject. So, yeah. So, have a good night. Rest well. And I wish you most success. I wish you all of the success in your exam tomorrow. Yep. No. I'm gonna... Hi, Yuki. Hi, yo. Long time no see. What? Kann ich schließen? Wie geht's mir stets? Entspannt soweit, bisschen erschöpft. Hab bis gerade eben noch meine Mathe-Lektion durchgezogen. Jetzt mittlerweile knapp 2 Stunden her. Du, ich kann sagen, ich bin... Halt, stopp. Ja, ich hab... Haha, ich habe meinen eigenen kleinen Hintergrund hier. Aha, ich hatte gerade eine Benachrichtigung, aber Twitch hat mich nicht informiert. Danke. Twitch. Oh, it's sleeping. Wieso uff? Wieso uff? Wenn du ein guter Mathelehrer bist, kannst du das Zeug auch rüberbringen. Ich habe bisher noch keinen Schüler gehabt, der durchgefallen ist. Yuki, es ist nicht kompliziert, wenn du weißt, wie es geht. Wenn du einmal weißt, wie es geht, dann ist es absolut nicht kompliziert. I'm sorry. Is PlayJ right? As you learn all engineering stuff if you are not going to use it. Or maybe you can go for a professor fee. Yeah. Yep, you're right. Okay, bye. I wish you the maximum, I wish you the best results. Best luck in your exam tomorrow. So. Jetzt bin ich am Überlegen, was ich noch mache. Ist jetzt mittlerweile auch fast 3 Stunden dabei. Ne, 2,5. Sehr gut. Jo. Genau. Nun stehen wir da. Tschüss. Und wie ist es dir so ergangen? Wenn du willst, kann ich dir die Sachen ja auch gerne... Kann ich die ganze Mathe ja auch nochmal vorführen. Für deine Freude. Nee. Der lebt in Indien. Für den ist es relativ spät und der hat am nächsten Tag... wie gesagt, India hat am nächsten Tag eine Prüfung. aka wahrscheinlich in ein paar Stunden. Oder am Sonntag, je nachdem. Bei dem müsste jetzt mitten in der Nacht oder sehr früh am Morgen sein. Das heißt, er hat jetzt wahrscheinlich noch was zu tun. No. Alle Dude. So, was kann man so schönes, interessantes hier noch machen? Jo. Ach, ich glaube, ich bleibe erstmal bei Just Chatting. Das ist doch auch Spaß. Jo. Wie gesagt, wie ist es dir so in der Zeit ergangen? Seit Mittwoch. Ist der Stream dann gut gelaufen? Hast du den Leuten mit deiner Stimme imponiert? Etwas. Oh, ich verrenke mir den Kopf. Aha. Das sollte eigentlich direkt geradezu sein. Bupp. Reset Position. Perfekt. So soll es sein. Ja, ich bin munter nun. Die erste können wir machen. Was ist das für ein kleines... Was ist das für ein kleines Kind? Jo. Kann man machen, muss man aber nicht, ne? Du bist arm dran. Da bist du echt arm dran bei der Sache. Oh. Oh. Oh nein, oh nein, oh nein. Ah. Weiß ich noch, wie alt du bist? Halt, stopp. Du hast mir nie erzählt, wie alt du bist. Daran würde ich mich erinnern. Ich habe so wenig gechattert, daran würde ich mich erinnern. Das hast du mir noch nicht erzählt. »24, du bist ja gar nicht so weit von mir entfernt.« was? Oh. Ganz weit weg vom kleinen Kind. Ja, Argument. Oh. Kleine Kinder sehen 24 schon als halb tot. Kann ich dir aus Erfahrung sagen, ich bin älter. Ich sehe mich als fast tot. Ah. Oh je, ja. Jupp. Ich wünschte, es wäre anders. Oh, die Jugend heutzutage. Die Jugend. Die jungen Leute heutzutage. Die jungen Leute heutzutage. Naja. Du bist bei mir noch nicht tot. Ich mach dich trotzdem weiter an. Ja, das kannst du gut. Das kannst du sehr gut. Ah. Oh. Oh. Hätte ich mir gedacht, dass du vorbeikommst, hätte ich mir auch ein paar Sprüche für dich zurechtgelegt. Oh. Oh. Ich muss jetzt gerade mal alles umbenennen. Ich weiß nicht, dass ich das gefreut hätte. Ich bereite es mir fürs nächste Mal vor. So. Streaminfo erfolgreich aktualisiert, sagt er. Mal sehen, ob es auch stimmt. Mal sehen, ob der das auch so gemacht hat. Manage Stream. Jawohl, hat er auch übernommen. Wäre ich ein Creeper, würde ich... Wäre ich ein Creeper, würde ich nur dich stalken. Du kannst mich gerne stalken. ah. Ja. Machst du eh schon. Ja. Kann ich nichts dagegen sagen. Kann ich nichts dagegen sagen. Oh. Bisschen. Stretch. Ja. Du. Gib mir eine Sekunde. Ja, genau. Oh Gott. Ich habe jetzt gerade mal auch mal geschaut, was es so für Ansprüche gibt. Ich will es nicht riskieren, dass TOS mich sehen. Das wäre etwas unangenehm. Du gibst mir sogar 2 Sekunden. 2 Sekunden. Was will ich denn damit? Okay, was willst du denn morgen zum Frühstück ans Bett geliefert haben? ah. Puh, das ist noch. Noch ist grenzwertig. Ich muss aufpassen. Nee, durch meine ganzen Neptunia-Streams bin ich ein bisschen ins Kreuzfeuer von TOS geraten. Die haben mir schon eine Warnung geschickt. Eier sind gut im Frühstück. Das stimmt. Am Morgen immer 2 Eier essen. Was? Aber gut, wenn man viel Sport macht, sollte man auch viele Proteine mit zu sich nehmen. Muskeln müssen ja bekanntlich auch funktionieren und wachsen, wenn man sie beansprucht. So, ich kann jetzt auch mein normales Logo ein bisschen runternehmen, weil ich das hier auch drauf habe. Haha, Doppellogo. Problem ist, ich kann hier meinen komischen Panto nicht ganz einsehen. Twitch ist ein bisschen verbuggt bei mir. Ich weiß zwar nicht warum, aber irgendwie sagt mir Twitch, ich darf keine keine Extensions dort benutzen. Was mich ein bisschen irritiert und nervt. Die ganzen Twitch-Extensions funktionieren bei mir nicht so ganz. Hey Praline, war's nach einer Kräfelung? Oh. Ich weiß, ich sehe hier auch schon. Ich bin vom ADAC. Ich bin hier, um dich abzuschleppen. Was ich niedlich fand, was ich gefunden habe, ist, wenn du nicht weißt, wo du mit deinen Händen hin sollst, gib sie mir und ich halte sie für dich fest. Das war niedlich. Den fand ich nicht gut, aber niedlich. Ah. Und vom Typ kann ich deine Hupen testen. Ah. Oh Gott. Ich sehe gerade. Ich glaube, ich benutze dieselbe Seite wie du mit deinen Anmachsprüchen, weil ich deine hier immer mal wieder finde. Unter billige Anmachsprüche. Ah. Ja, 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 würde ich wahrscheinlich so unterschreiben. Du kannst die mittlerweile ziemlich gut, ja. Hm. Ich finde dir gerade interessante Anmachsprüche, aber sowas wie ich finde, mein Nachname passt gut zu deinem Vornamen ist irgendwie komisch. Ich meine, das ist als Anmachspruch. Hm. 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 Ein bisschen fix für ihr. Jemanden einfach so ansprechen und dann schon. Ist mir dein Name oder soll ich direkt. Kann man dich eigentlich für Geburtstage und Firmenveranstaltungen buchen? Verdammt. Ah. Musst du eine Türe wollte ich dich die ganze Nacht knallen. Ich bin Filmemacher. Willst du mal auf meine Besetzungscouch? Ah. Der tut weh, wenn ich es sage. Der tut echt weh, wenn man es sagt. Ah. Ich spüre metaphorische Schmerzen. Ein Geheimnis kann ich dir ja verraten. Es gibt einen Weg, Leuten aus speziellen Regionen aus... Was? Kennst du die Zahl der Liebe? 69, was? Zwei, 6, 8, 9, 3. Das verstehe ich jetzt. Warte, was? Wenn sich zwei Menschen mögen, dabei aber nicht 8 geben, dann sind sie 9 Monate zu dritt. Ah. Okay. Verstanden. Verstanden. Ah. Was haben wir noch so Schönes? Wie du aussiehst, hast du auch nur auf mich gewartet. Verdammt, ich habe die Toggles gar nicht. Ich muss wieder im Blender über mein Modell drüber gehen. Ich brauche noch ein paar Toggles. Ja, gut. Das ist was man anders mal machen kann. Oder ich höre jemanden dafür an. Rose Red. Roses are red, violets are blue. Pornhub is down, your Facebook will do. What? Ja. Den Spruch noch nie gehört. Ist ein bisschen. Ist ein bisschen außerhalb. Schön. 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 Darf ich dir ein bisschen Cringe geben? Du musst der wahre Grund für die globale Erwärmung sein. Mein Lieblings... Soll ich dir meinen Lieblingswitz erzählen? Na, erzähl mir mal deinen Lieblingswitz. Ich bin gespannt. Ich bin gespannt wie ein Flitzebogen. Geht ein Kind in einen Spielzeugladen, sieht einen Dino oben am Schrank, kommt der Verkäufer und... ich habe den Dino bekommen. Das tut schon ein bisschen weh. Habe ich was anderes erwartet? Ich habe auf was anderes gehofft. Kann ich. Ich kann anpinnen. Warum kann ich in meiner eigenen Moderation nichts machen? Ja, ich kenne dich mittlerweile. Das stimmt schon. Die Hoffnung stirbt zuerst. Die Hoffnung stirbt zuerst. Ich habe echt vergessen, wie man Nachrichten löscht in dieser Mod-View. Ich bin schlechter Mod. Tschupp. Dann ist es halt so. Schulz. Ha, ha, ha. Eigentlich wollte ich dich ja anbaggern, aber ich habe meinen Bagger leider vergessen. Dafür habe ich einen Löffel. Darf ich dich anlöffeln? Ja, früher habe ich nach dem Sex geraucht. Heute benutze ich Gleitgel. Ah. An dem Punkt. Gut, es ist 22 Uhr. Sollten keine Kinder mehr kommen. Oh. Den Zaubertrick kann ich gut. Ich meine, was? Hm? Ah. Ah. Sagen wir es mal so, ich habe Sachen gesehen. Das ist auch eine gute Story. Ich war mit 2 Kumpels in einem Club und wir haben ein bisschen um Geld gewettet. Ich glaube, wir haben gesagt, hier an zu dritt 50 Euro. Kumpel von mir, der größte Player von uns allen, geht zu einer hin und fragt sie, na, warst heute schon kacken? Und er hat die tatsächlich mit nach Hause genommen. Der Kollege hat noch nie leichter 100 Euro verdient. Naja. Oh, naja. Yep. 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 Ja. Oh Gott. Na, hast du eine gute Haftpflichtversicherung? Du hast mir gerade der Beule in die Hose gemacht. Ah. Au. Au. Der tut weh beim Sagen. Ah. Ich glaube an dem Punkt. An dem da kannst du mich wirklich ganz Becken stoßen. Ah. Oh. Ich bin Meister Propper. Darf ich mal dein Becken schrubben? Oh. Wie man das manchmal so aktualisiert. Ich habe das mal unserem Thema angepasst. Pickup-Lines und schlechte Anmachsprüche. Fassen wir? Fassen wir. Und was checke ich wahrscheinlich gerade nicht. Phasmophobia. Gute Frage. Lass mich schauen. Tatsache, ja. Ja, Tatsache habe ich. Bin zwar absolut kein Fan von Horror-Games, aber ja, ich habe es. Und um ehrlich zu sein, noch nie gespielt. Ich Ich weiß nicht, wann und warum ich mir das mal geholt habe, aber ich hab's. Das Geist wird sie mich nie wieder gehen lassen. Oh. Du gehörst dann wohl eher zu der Klasse Succubus als Geist, wa? Na. Du, Das Spiel war sehr ein Hype damals, deshalb bestimmt. Nee, ich glaube, ich habe mir das erst dieses Jahr gekauft, weil Freunde von mir das zocken wollten. Ich wollte es, glaube ich, auch mal on Stream mit jemandem anderen spielen. Ist bisher noch nichts geworden. Interessanterweise. Da fällt mir doch gerade ein. Da fällt mir doch gerade ein. Ja, viel Spaß beim AFK sein. Mein Gott, meine Freundesliste auf Stream ist zu groß. Wo ist... Was starte ich nebenbei? Weißt du was? Blub. Ich glaube, ich wechsle dann mal. Weiß schön mitten. Munkel, munkel, es ist dunkel. Eine Sekunde. Warum ist nicht funktionieren? Jetzt funktionieren. Weder denke ich bin männlich, nur weil ich direkt mit diesen Ansprechsprüchen ankomme. Ja, macht Sinn. Ich meine, ich verstehe, warum die das denken, aber... Naja. Okay, Twitch lässt mich gerade die Kategorie nie ändern. Warum nie? Wen juckt's? Wen juckt's? Ja, du kannst das gut mit den... Du kannst das gut mit den anderen sprechen. Das ist schon... Ja. Wenn ich Probleme suche, weiß ich, wo ich sie finde. Lass uns lieber fast mal zusammenspielen. Habe ich auch kein Problem mit. Oh. Ist chatting. Gut. Nicht nur jetzt. Du machst es öfter. Anmachsprüche. Ah. Oh, ich muss jetzt nur schauen. Wir sind, glaube ich, gemeinsam auf keinem Discord-Server. Ah. Für mich persönlich ist das kein Problem. Natürlich nicht. Nee, du hast mich nicht auf dem Discord. Das stimmt. Nee, ich hab dich auch nicht auf dem Discord. Man kann im Spiel reden. Also alles gut. Jo. Gut. Wenn ich das dann eingestellt kriege. Bin da nicht so schlau. Phasmophobia. Ach, da ist es. Ha! Mal sehen, wie ich hier die Einstellung machen kann. Phasmophobia spielen. Schaffe ich. Ich werde mal sehen. Oh Gott. Oh Gott, oh Gott, oh Gott, oh Gott, oh Gott. Ohne mich jetzt großartig outen zu wollen, ich spiele normalerweise keine, ja, Horrorspiele bin ich dann normalerweise nicht so. Oder Horrorfilme. Oh Gott. Bitte kein Crash. Okay, es läuft noch. Okay, mein. Das heißt, paar Sachen hier. Du spielst fast nur Horror. Kann ich mir vorstellen. Auch wenn du streamst. Ohne böse sein zu wollen, aber wann streamst du mal? Ich habe dich bisher noch nicht streamen gesehen. Das heißt, ich konnte die Behandlung noch nicht umdrehen. Computer, bitte sei kein Problem. Jo. Mal sehen, wann Phasmophobia lädt. Bin ich ja mal jetzt echt gespannt. Zuschauern geht ziemlich alle 2 Wochen. Ach so, okay. Ich glaube, wenn ich nach meinen Zuschauerzahlen gehen, streame ich vielleicht einmal im Monat oder sowas. Ah. Computer! Phasmophobia, Sebast. Ich würde ja sagen, danke, aber momentan scheint Phasmo nicht mitzuspielen. Mal sehen, ich starte es nochmal. Phasmo normal. In der Hoffnung, dass es funktioniert. Hoffnung stirbt zuerst. Oh, jetzt funktioniert's. Noch. Mal sehen, wie lange das dauert. Photosensitivity Warning. Loading Game. Nee, das. Je nachdem, wie es läuft, kann das auch auf Gegenseitigkeit beruhen. Ich glaube, nächstes Mal, ich muss mir für Phasmo mal heiliger. Wie viel Power braucht denn das Spiel gerade? Also, Phasmo ist ja qualitativ jetzt eigentlich von der Grafik und so weiter her jetzt nicht so krass. Aber bei mir braucht es jetzt zwischendrin immer mal wieder 1 Gigabyte Arbeitsspeicher. Das ist schon. Wieso sagt der mir hier 2 Anwendungen? Crashhändler. Jo, Phasmo mag mich absolut nie. Task beenden, bitte. Danke. Also, ich kann jetzt definitiv ohne Bias oder irgendwas sagen, ich glaube, ich muss Phasmo nochmal neu installieren. Ah. Mein unguter Freund Phasmophobia. Es scheint mich wirklich nicht zu mögen. Okay, dann ist es halt so. Muss ich es mal neu installieren und dann können wir es auch mal offstream miteinander zocken. Naja, passiert. Ich mache einfach wieder meine Background-Musik rein. Und freue mich, dass ich noch existiere. Und dass mein Stream noch nicht gecrashed ist komplett. Nichts wirklich zu meckern an meiner Stelle. Naja. Ich denke, ich werde dann auch erstmal raiden. Weil ein guter Freund von mir macht nämlich heute Geburtstag. Noch, genau. Deswegen werde ich jetzt die Chance nutzen, ins Dashboard zu gehen. Manage my Stream. Und dann machen wir mal... Weil ich selber nicht zocken kann, raide ich einfach mal in... Ah. Das ist der falsche. Twitch. Da ist er. Bye, bye. Ja. Einen schönen Abend noch. Und dann reden wir mal zu unserem guten alten Iggy. Der spielt nämlich auch Phasmo. Haha. Gute Nacht.